So first things, let's kick off into like an introduction. If you aren't familiar already into what is vLLM, uh, Simon, do you want to take this?
Yeah, of course. So for folks who are very new, I just want to give a quick overview of what is vLLM. vLLM currently is the uh, leading open source framework where you can deploy open source a large language model in production. And our feature set is really covering both supporting a wide range of open source models as well as a wide range of hardware accelerator and make sure we can the software can run the model efficiently and effectively on these hardware with a whole suite of optimizations such as quantization, prefix caching, tensor parallelism. We also offer APIs so you can both use offline batch inference where you pass in a large batch of data and you run it through the LLM or online serving in your OpenAI compatible manner so that you can easily switch off the application to use open source large language models.
Yeah, well said. Obviously we can answer more questions on that further, but next up we'll talk about what neural magic is and what we do. So our focus in neural magic is we really believe in open source AI is the future, and we want to bring open source LLMs and vLLM to more people and more enterprises, and getting it integrated and getting people to understand why this software is so important to build your next generations of LLM serving on. So we build different enterprise inference servers for CPUs and GPUs. So obviously we're a big contributor to vLLM now. And what we offer for enterprise companies is sort of supported distributions, support for implementing things, all the things you need to sort of get in production in terms of telemetry and dashboard and Kubernetes configurations. So yeah, we're really excited to be here and contribute and be a part of the project, and yeah, get vLLM into production for more people. We also make optimization libraries for optimizing your PyTorch or Hugging Face models, so that you can compress models with sparse ML to lower bits, or with sparsity, or all sorts of techniques to make models smaller or have greater throughput for serving. So next up, we'll just we want to like jump into like what's happened since the last office hours. The big thing was the 0.4.3 release of vLLM. Obviously, a lot of things here. Here we sort of summarized a lot of the nice things that Simon put into the detailed release notes. So just some of the top level things are support for a lot of the new models that have come out over the last 3 weeks or maybe a month. Like Snowflake Arctic and Feed 3 small, which has these interesting block sparse / tension kernels that Microsoft researchers themselves contributed, which was really cool. Another thing that's sort of on early support is support for embedding models. So vLLM has been building for a while on supporting more than just text generation models. First, they kind of started with multimodal, making vLLMs, vision language models, which we're putting broadly under multimodal. That's still that was sort of the first starting point, and a key next step is adding support for embedding or encoder models, which you can now access through LLM encode and through the OpenAI style API. We're continuing to work on encoder decoder as a next step after this. So definitely look forward to more types of model architectures running in vLLM beyond just causal LM text generation. As I mentioned, multimodal refactoring has been a big project as we work to get the interfaces right there. So there has been some slight churn on the interface for multimodal models, but this goes towards normalizing the input format so that you can pass in text prompts, already tokenized prompts, or various, already not tokenized, but processed data directly to to the LLM that is going to take your image data, or in future your audio data or video data, already tokenized and turned into embeddings for the model to process for generation. There was a lot of work on AMD, improving fused MOE performance, tuning the Triton configs, and actually getting Punica kernels supported, which is for batch LoRa support. So good to see progress there. On sort of the production engine side, which was a big push this quarter. This was for supporting the sort of new batch file format on OpenAI, and getting Ray as a optional for, I believe, tensor parallelism. We sort of ran through and implemented this. Now, I think by default, if you don't have Ray installed, it's uses Python multiprocessing to perform communication across processes of vLLM. And we've been working a lot on prefix caching to get the performance higher. And one of the key things there was sort of the hashing needing to get tuned. We've been doing a lot of work, particularly on quantization. Particularly the Neural Magic team has been involved a lot on this. We contributed a start for sparse kernels in vLLM using the Marlin 2.4 sparse kernels. We'll be following up Neural Magic in the coming weeks on models we produced, accurate models that we produced in this format. And we're really excited about showing the performance and usability of these models in vLLM with the kernels we've added. We've also been incrementally adding support for models coming straight from SparseML through the compressed tensors library. So this is connected with support for W8, A8 models in vLLM, most notably sort of int8 quantized weights and activations, but also looking forward and building infrastructure for combining, W4 A8 or actually quantizing models beyond just the linear layers. So definitely we'll share these slides, and you can click through all these various links to issues in here, or links to PRs in here, but definitely dig in on the things you're interested on, and of course ask questions later in this presentation. Flash attention, landing for decoding. I'm not sure if there's a great or sort of performance results to really show on this at the moment, but it's definitely a good step towards getting a better attention kernel and working sort of the interface that landed, I think, in the past release or two of allowing for mixing and matching different attention kernels. A lot of work on the FP8 support from Neural Magic and the Anyscale team. We're really excited about that and starting to see really good performance results. So I think we're excited to start pushing some content and public flows on that in the upcoming release as planned. And sort of just overall, there's been optimization for the sort of all reduced and distributed communication in general. This has been useful for tensor parallelism, but is also, kind of connected to the pipeline parallelism work, which is, I think, just started within this release in preparation for some of the larger open source models that are coming out, particularly like Llama 3, 400B, 400B plus, however large it's going to actually be when it comes out. That was a lot of stuff. Feel free to ask questions already on this, and we can, either in chat or as we go through, I think, 2 more slides here, you can just start talking. So one thing we wanted to call out, especially for some of the people that have been returning here and maybe already have experience with vLLM and want pointers on how to contribute. Here we've pulled out some of interesting issues or RFCs and sort of calls for help or assistance if you're interested in contributing. I think these are some pretty good starting points on a variety of different issues and features in vLLM. So hopefully If any of these have an interest to you, please ask questions. Happy to clarify or give you a starting point. And also, you're welcome to start having or joining the discussion in GitHub. So yeah, there's that. Of course, they'll be shared in the slides after. And yeah, we'll jump into some questions that were asked at the sign up for this meeting. So to first start, it's sort of not exactly a vLLM question, but a general optimization question of like, what impact does post-training quantization to low bits have on accuracy at inference? Yeah, this is a pretty general thing. So if the person or a person who's interested in this question is in the audience and wants to ask specifically, you're welcome now to step up. And if not, I'll just start talking on it. So generally, obviously, it's a range here depending on how many low bits you're going to. But generally, we see with FP8 post-training quantization, you can generally have like less than 1% impact pretty safely with just sort of per tensor scales for choosing how to quantize the weights and activations. That also gets into the differentiation of, are you quantizing just the weights or also the activations? Sort of current research shows that you can generally quantize your weights down to 4 bits just with post-training quantization using a calibration set of data, say with like GBTQ or AWQ, and get pretty acceptable, like less than 1% drop in accuracy. However, once you start including activation quantization, activations have quite a bit more variance and outliers and large ranges of values. So generally for activation quantization, it's found that sort of 8 bits is sort of the maximum. And you can even have issues in if you're not careful on some particular layers. Like we found from our research, actually, this is a good point to share a blog we wrote on this for Llama 2, I think, back in the day. This was actually on CPUs, but the quantization applies same to vLLM or wherever you're quantizing. But in the latter half of this blog, you can see, well, actually, we're showing a window, so I can just scroll. When like looking at the ranges of values in the input activations of Llama 2, this is really technical. You can see there's just like a few layers that have really, really large input activations, whereas the majority are in like the 40s or like really small ranges of values. This is just taking the max minus the min. But for some really specific layers, it's just huge ranges, and this really hurts your accuracy if you quantize these models without this knowledge. So this is something where having floating point formats that have dynamic ranges, so you can catch really large variances in the input activations, helps. This is something where int8 or an integer format that with a fixed range doesn't work so well. But yeah, it's kind of an open question. So definitely, as you have more specificity, we can help out with that. So another question is how to maximize the usage of a full A100 node for running one Llama 370B. I think the obvious question here is just simply keep it at original, FP16 or BF16 precision and run it with a tensor parallelism of 8. This is going to write optimized for, I guess, the best time to first token. It's going to give you a lot of compute available. So if you have really large prompts coming in, or really large batches of requests, hopefully you can get the best throughput or latency. If you're truly loaded, if you're maybe at a medium level of sort of request intensity, then possibly looking for a quantization method such as GPTQ. So reducing the size of the weights down from 16 bits to 4 bits and running using the Marlin kernels that we've contributed, you can see really large benefits in the time per output token for maybe a small trade-off in your prefill time if you're getting large prefills, where you can maybe run the model because it's also only going to take maybe 35 or 40 gigabytes rather than the sort of 140 gigabytes the model would take if you had it in FP16 precision. You can run it on less GPUs, so maybe just run it on 4 of the GPUs or 2 of the GPUs, and have more replicas. So sort of have multiple servers splitting, have 2 or 4 model instances on that one node, and target faster latencies for sort of the and put sort of a load balancer on top of those parallel servers. So it really kind of does depend on the workload that you have working. If it has like really large prefills and many concurrent requests, or say if it's a lot of small prefills and a lot of output generations, this is going to change how you want to configure this. And this is something we spent a lot of time benchmarking and profiling. Prefix caching, I sort of took this as a general update on prefix caching. So if you remember, we actually went over this in the previous office hours. So I actually have some of these slides here. If I can, just pull it up. So prefix caching is just where if you send a request, so sort of on this left-hand side, a prompt asking what is AI, and the LLM responds with its request. If then you write in like a chat scenario, are going to send that same prompt result, and then now with your new prompt, cool, thanks. The automatic prefix caching makes it so that if there aren't other requests that have bumped out those previous computations, essentially if the previous computations are still cached, which they will be under low load or lots of reuse, then the vLLM server doesn't need to do any recomputation of those previously seen prompts or generations. So it allows you to have faster time to first token and less energy usage because you don't need to redo redundant computation. And you can enable this just with the enable prefix caching flag in the server or LLM class. Back to this. Okay, there was a Spanish question. I'm not going to pronounce it because I can't speak Spanish well. But how does a pipeline for multiple thousands of queries work? Also a pretty general question, but definitely we could say, like in the case of offline batching, so using the LLM engine class directly, you would just say provide your like thousands of prompts in parallel, and it's going to vLLM has calculated or has set a sort of maximum number of tokens roughly to process. It's sort of a function of how many prompts can it batch together, and based on the available memory that you have pre-allocated for the page detention. And so it's going to try and run all of those prefills up front, I believe, and then, or it's going to run all the prefills it can to satisfy the batch of work that it has, and then it's going to start doing continuous batching for those prompts. And then as you get, as prompts or as those generations finish, then it's going to introduce more prefills that can fit in and keep the batch at its maximum size until you finish all of your generations. So it's going to do its best to, process each prompt as it can until it gets to its maximum working batch size. And the remaining queries are going to be blocked or waiting until the previous queries finish, and they're going to insert as they have room. Yeah. And for minimizing hallucinations and data augmentation, how do you architect advanced prompting? I think this is kind of a research question, kind of difficult to handle within the context of just LLM serving. But I think there's definitely a lot of research out there to read into, synthetic data generation or continued fine tuning or, RLHF in order to guide models or, unfortunately increasing the model context through adding more verbose system prompts and other things in order to guide the model and its generation to hopefully avoid things that it's unsure about or caveat things that it's not completely confident about. So that was really kind of grinding through a lot of the questions we have ahead of time. I think since no one stepped up for those, we can definitely get into questions that have been asked so far. So
I didn't pull that easy, Michael. Do you want to ask, or do you want me to?
Ask. You said a poll?
Yeah, I have all the questions in chat pulled up. We have a handful of questions there.
Okay,
starting with Ron. Yeah, so Ronald asked, what all features are currently in TGI and not in vLLM? He wanted to find out our perspective. Maybe Simon, if you want that.
Yeah, I can speak a little bit. TGI is a great system. So, so far, we identified the biggest gap that are in TGI but not vLLM is the ability to run arbitrary Hugging Face model. So, vLLM, you can run most of the Hugging Face models available on Hugging Face for language generation. And as Michael mentioned, we're adding more. TGI had this feature to run unoptimized models that are now covered by the optimizations, which is a capability that we haven't got to add. Other than that, we actually think we have pretty good feature parity and sometimes even more features. But we would love to see always keeping this updated. Yeah.
Yeah, I think I'm trying to think. Oh, here, the supported models list.
Yeah, we have this list right here. Yeah.
Yeah, there are a lot supported. I actually just checked for an issue that there are like 35 different model implementation files in our models directory, with many of them running within Llama, because obviously many of the models that come out are sort of based on mostly compatible Llama architecture.
Thank you, Ronald. If that doesn't give you enough info, feel free to jump in, ask via chat, or just speak up, please. There was a question about it. Does vLLM have a Slack or Discord? Yes, vLLM does have a Discord. I posted a link to the Discord as a reply to your question. So Neural Magic has a Slack instance you can find on our website, and vLLM has a Discord. Thank you, Max. And then Tim, I'm not sure, Simon or Michael, who wants to take this one. But the question is about load balancing features. So are load balancing features supported by vLLM if I run a few instances of the engine?
Sure, I can get started. So right now, this is not directly within scopes of vLLM, where our job is to run a single model of a single instance on a single GPU box, because something need to run multiple GPUs efficiently and effectively. And then you have layers of software to perform the load balancing. Of course, it's something we're looking into from a research point of view. But so far, people have been very successful, in fact, running vLLM in Kubernetes using the cloud native like Kserve or other directly load balancers to orchestrate multiple engines in production.
Yeah, that's totally right. And there are like Prometheus metrics and things exposed by the vLLM server so that you can hook these up and get more sort of clear both metrics for visualization of your scaling, and also build better automated rules on when you should choose to auto scale, or if a particular server is overloaded and you should route towards another server. So it's definitely meant to build on top of as a single node, or as a sort of single node or a few GPUs inference server. There's a question from
guys.
Joshua.
Yeah, go ahead. You can take it over.
Yeah, on how's the cache managed long term? I'm assuming this is related to the prefix caching. At the moment, I think least recently used is the method. Yes, yeah. But there is a capability for other methods to be implemented. It's pretty simple, just Python code. So definitely, if you're interested in anything else or developing on that, we can share the RFC or tracking issues for prefix caching and work on getting those implemented, or shepherd any features that you're trying to get implemented. Okay, from Tim, for the question on maximizing usage on a full A100 node, where can I find more information on the list of tricks mentioned? I'm not sure of a good direct place to find all of those, particularly on a full node system. As we've we've done it within Neural Magic, is sort of more on one-offs and with conversations with like specific clients or workloads that we have submitted from people, and exactly working out, right, like, okay, you have like sort of a RAG workload or summarization, and based on those general input and output distributions, this is how we think you should set it up. But sort of, making like a general guide, because of all of the complexity that we talked about, it's a bit difficult to sort of make that and have it be a single source of truth. But I think that's definitely something we want to provide to the community more, in sort of, coming up with or providing some of the common scenarios that we hear about or know about, and essentially just, trying to make a best practices guide for that. I think that is something that is, missing from documentation currently. I don't know. You have a thought there, Simon?
We should do more on the documentation side. That's point as things we're missing. Thank you for that.
Yeah, definitely. There are like some things we've shown, I think, on just like single GPUs though. On like when we released the Marlin blog for on vLLM, we showed some things like, this is just on like an A10 GPU for a 7B. So nothing really intense like that. But some of these like experiments that we go through here of I really kind of just recommend like going through the benchmarking scripts that are in vLLM and running on the server and measuring yourself, with different methods here, are going to give you, sort of the best results. And hopefully you have your data represented in some sort of format or distribution that will allow you to profile those workloads. Otherwise, that's definitely something that, figure out how to get information. But definitely we should, I think, a performance guide that goes through all the steps required to do that, understand the distribution of your data, your workload, and plugging that into the benchmarking scripts and evaluating on a few different methods. I think that's a good item that, I think I'll take on, and writing at least an issue for to track it. So thanks. I think that's most of the questions asked in text. Does anyone want to submit any more, or want to turn off your mic and ask in person?
You answered mine. Thank you.
Okay. So there was a question asked. I played with a few inference servers, and I feel really excited about the inference space and want to contribute. He suggests some resources, guides I should progress to maximize my learning. I mean, I think there, like, if you're interested in inference, it kind of like from what perspective? Like, are you interested in inference for the pursuit of inference, or if you have like a an LLM usage that you're interested in? I think using one of the libraries or sort of toolkits for using LLMs to do interesting things like DISP or LangChain, or and using vLLM as sort of the backend to power your usage of the LLM, for serving the LLM. Those will give you a good feel for what kind of optimizations or features are missing in the LLM server that would maybe serve for those usages of the LLM API, that I think would help ground your understanding in what are the inference use cases and what features are you going to be interested in. I think that's the best way to meaningfully contribute to software, is developing your own needs and requirements. I think definitely looking at some of these issue requests that cover like a lot of different categories, such as the continued work in multimodal, or getting vLLM to work better on CPUs, or working on speculative decoding, or lots of other things, like even sort of relatively simple things on paper, like computing the like serving flops. This is like something you can do sort of entirely in probably in Python, and just like estimating the flops of the model and how good your utilization is. But this is absolutely like important going forward for getting everyone to understand sort of how close are we getting to speed of light performance. Yeah, it's obviously a good way to get some love from the other people in the community for implementing features that people want but can't quite get to. So we'll share these slides afterwards, or actually, yeah, we will share them afterwards, but let's also make sure to share them in the here in the presentation. So yeah, definitely check out these issues and other issues, and look for the good first issue tag on vLLM. Yeah. So another question from Tim: could you explain the difference between using Ray or tensor parallel when running on multiple GPUs? I think it depends on where you're asking it from. So like, you could use Ray to like run multiple instances of vLLM. So like running multiple models or multiple instances of the same model on multiple GPUs, sort of like as replicas, because it is kind of a similar framework to Kubernetes in that way. But it's also used in order to do tensor parallelism on multiple GPUs within vLLM. Although now there's some work to make that optional or allow for other methods for doing that. Yeah, I think that's close. Okay, cool. Appreciate that. How hard would it be to integrate a new parallelization lib? I don't think it would be that difficult. I mean, the clear thing is, I don't know. I'm not sure exactly how I'd find this right now.
Yeah, search for like multi-processing executor or something.
Yeah, here we go.
Yeah.
So I would.
The short idea here. There's like two things here. One is a distributed or parallel runner. Essentially, what do you use to orchestrate the processes? So in the past, I've been using Ray, but in some cases you don't want to use Ray, and this is where IBM added the multi-processing GPU executor, which is based off just which is based off just Python multiprocessing library. I believe AMD is also adding Torch Run, like the PyTorch native multiprocessing as an option to this. And then, so this is kind of the parallelization backend. But then on the parallelization, how do you actually shard the model is a whole sort of another layer, kind of orthogonal to this. So far we'll support a tensor parallel method, which means every forward pass will run through all the GPUs for every single sort of matrix multiply operation. So this maximizes memory usage and compute. And we're working with a different company called ScentML to add pipeline parallel. This will kind of cut the model in like across stages, so that like first half of the model running one GPU, second half running other GPU, and this will improve throughput in especially low sort of, for example, 3, 4, 8, and G connected over a slow network, like not InfiniBand networking data centers. So that is an alternative parallelization strategy using pipelines to improve throughputs. And that is also in progress in the work. So as we add more and more different kinds of parallelization strategies and backends, we hope it will be more and more modular. The code will be more and more modular, easy to add, easily abstracted. So in the end, vLLM's goal is to make everything super easy to swap out, so you can essentially use your component to optimize it.
Yeah, very well said. And if you look at the PR for the multiprocessing GPU, you can see that like it only took really 200 lines to achieve this. And I believe it was sort of the first example of making a multiple GPU executor outside of Ray. So yeah, hopefully this will get easier and easier for some of the at least easy to implement alternatives. Yeah, so Justin's seen issues with gibberish or mixed up generations when running vLLM in the Docker image. Yeah, it's hard to say if this is, ultimately, if you can make a minimally reproducible example, that's the key thing here. We have had, some instances where there's like issues here, but depending on the model you're using and the precision you're using, there is maybe, still some risk of hallucination with the models or sort of instability with the models. So yeah, like in terms of troubleshooting, it really is, I think, trying to get a minimal reproducible example. If you can do it, say in the offline batching interface, that would maybe be a little bit more deterministic than on the server. But yeah, it's hard to tell if you're running into any non-determinism. Another thing would be like if you can trigger it using greedy decoding, or if it only shows up when you're using a non-deterministic sampling scheme. Yeah. Any other questions? We're getting to the close to the top of the hour.
Well, let's go to how to get involved slide, and then
sure,
a bit more questions will come as we quickly run through that. So we'll be here. We'll stay as long as we have to. As long as you guys need us to. So feel free to ask any more questions. Don't worry about time. So there's many ways to get involved with the vLLM community, even more so than 3 weeks ago. So in addition to the features that Michael shared a few slides earlier that are very important and really help it, you can always check out the good first issue tags and start contributing there. Another thing is just building examples and demos with other tools. So the more we can create and share with the community, the better that will be. And talking about sharing, so if you are working on if you have a vLLM use case, doesn't matter if it's in production or not, we would love to bounce ideas by you. Come to the Discord, come to Neural Magic Slack. Somebody's gonna jump in and help, and we'd love to just, as I said, bounce ideas. And then as a marketer, I would love to also share your work with other people. So we do have a monthly newsletter that goes to an audience. So if you have anything that you want to share, including your use case or project you're working on, we would love to share that with the wider community. We want all of you also to become vLLM regulars. So there's a couple of things you can do there. So there is an event next week on June 11th. Is the fourth quarterly meetup for vLLM, and this is in person. It's in San Francisco at the Cloudflare offices. Simon, please correct me if I'm wrong. That's happening June 11th, and there is a wait list, I guess, fortunately and unfortunately. So if you want to meet everybody in person and come join there, please join the wait list. I can actually put the links in chat right now as well. Oh, Michael, thank you. We shared the deck. I didn't realize that. Our next office hours, as I mentioned before, is on June 20th in 15 days. So please join that as well. And again, if you think that we should be doing different timing or different days or something to make it more, better for everyone, just share that feedback, please. And in October, the Ray Summit is happening. So check that out. Michael linked it. Thanks, man. You can submit a talk to the vLLM track and just attend in general. So the link is right there. I believe the talk proposals are happening fairly soon. I think maybe it's even due next week. Simon, do you have any more info on the Ray Summit and vLLM talks?
Yeah, so essentially where so far I've been just doing meetups, and INSCO had this Ray Summit over the last few years, annual, and they have this big event every year, and then a good venue in San Francisco. So they are kind enough to offer up the entire track for just about vLLM and for vLLM user to discuss and about LLM inference and communicate and sort of foster the community together. So this is where we hope everybody can, if you are interested, you can participate in the Ray Summit, or even better, submit a talk if you want to essentially talk about your project and product around vLLM. We're happy to see you there.
Awesome. Thank you. And one last call out. So Neural Magic, we're on a mission to really bring open source LLMs and vLLM to every enterprise on the planet. I know that's a lofty goal, but I think it's a goal that we all share in this call. So we're hiring for vLLM engineers to help us accomplish this mission. So we have, not all of the positions are vLLM engineers, but definitely a handful. If you go to neuralmagic.com/careers, you'll see, I believe, about 10 roles that we're hiring for. So if it's not you, maybe you know somebody in your network, maybe you know a friend, a colleague that's very passionate about vLLM and bringing vLLM to every enterprise on the planet with us. So if that's the case, please check out our careers and join our team. Did we get any questions? I think we got one more question. Is there a possibility of LLM events in Boston, Massachusetts in the future? I'm happy to answer that unless Simon and Michael, you want to?
Yeah, I mean, go ahead. You would put it together.
I think the possibility is a good word. Absolutely. Absolutely. We actually tried to make something happen in the June timeframe, but then the office hours didn't take priority, but just felt a little bit more reasonable to start like this. So the interest in vLLM is real. Everybody can see that. So let us figure something out. We would love to. I think Neural Magic definitely would love to step up and host something, whether it's in our office. We also have ties to MIT and get a venue there. But just you asking that, Naga, thank you so much for asking. And there's others in the Boston area that are interested, or even East Coast in general. It can be another city as well. In addition, if there's others that are interested in joining in person, let us know. It's always good to know that people will actually come, and we'll definitely try to organize something probably in the later summer. I would say it's tough to commit to a month right now, but let's think sometimes later summer.
Yeah, awesome. Well, I think that's basically the chunk of what we wanted to go for. So thank you all for joining. If there's any more questions, happy to stay on further and talk directly, or happy to talk to you on GitHub. So thanks, folks. Really appreciate you showing up.
Thanks, guys.
See you in 2 weeks.
Yeah.
Thank you.
See you around.